Okay, let's look a little bit more at our function notation. Let's start with this linear equation. We know it's linear because it's in the form of y, right? F of x is the same as y. Y equals mx plus b, right? So it's still in this form of y equals mx plus b, which we know is the form of a line, right? Okay, so the f of x is the y, m is the negative 1/3, the slope, and b is 4. That's our starting point. So we're going to look at the graph of this in just a minute. But first, what I want to do here is I want to look at what happens when we have f of 6. Okay, so we're going to talk about what happens when we plug in 6 into our equation. So what that means is everything stays the same, right? So I still have negative 1/3. I'm going to plug in 6 for x, and I'm going to add 4. Okay, so we know the way this works. What happens is that the 6 and the 3 cancel, so I end up with f of 6 is the same thing as negative 1/3. Sorry, we can write this as times 6 plus 4. Right? So we know 6 and 3 will cancel out, and that'll leave us with 2 on the top times the 1 plus the 4. So negative 1 times 2 plus 4, which is easy for us to find. We're going to get negative 2 plus 4, which is just equal to 2, right? So what we end up getting is that if we plug in 6, we get 2, right? So we've done an example like this before in the last video where I plugged something in to my equation and I found out how to either, set something equal or to plug something in, right? So this isn't new, this is just review, but let's look at what this looks like on a graph. Okay, so here I've graphed the equation, right? So remember our equation was y equals negative 1 over 3x plus 4, and so negative 1/3 x plus 4. So that means that our starting point needs to be at 4. I have a negative slope, so I'm going to go down 1 and over 3, right? Down 1, 1, 2, 3. I land back on my line, right? And go down 1, 1, 2, 3. Down 1, 1, 2, 3. So we already know what happens when I plug in a value of 6 into my equation. When my input is 6, my output is 2. But let's say we didn't find this beforehand, and I'm asking you, what does it look like when you plug in 6 into this equation, right? So the way this works is that we go to the line x equals 6, right? So we go to our x-axis and we find 6, and we go up and down that line all the way. Okay, and really what we're doing is we're looking at when does this up and down line, this vertical line, intersect with my graph. Once I find the place that it intersects with my graph, I will go sideways until I figure out what that value is on the y-axis, right? So I go to where x equals 6 on my left and right, my input of 6, and I move upwards until I hit my graph, and then I move sideways. So what does this look like if we were doing this from scratch? Okay, so what I would do is I would plug in 6 until I hit my graph, right? So this is 5, this is 6. Then I move over until I figure out what my output would be, right? So what is my output going to be? It's going to happen at 2. And if I look at this as a point, right, that's where it hits when I plug it in, and that's what I'm getting out. If I look at the label of that, 6 and 2. I plug in 6, I get out 2, right? So that's what we're looking for when we plug in values, right? I know what the input is, so I go to my inputs on the left and right, and I just go all the way up and down that line until it hits my function, my graph that I have. And then once it hits my graph, I will go over until I hit my y-axis. And wherever it hits that y-axis, that will be the output value, right? So I plug in 6 and I get out 2, right? So remember, lines that are x's, okay, let's turn some of these off, right? X lines move left and right on my graph, okay? So whenever I'm looking at inputs, I'm looking at whenever my inputs hit my graph, right? So if I look at an input of, let's say, 3, okay, and I want to know what I get out when I plug in 3, I go to 3, and this is where 3 hits my graph. It hits it here and has an output value of 3, right? So the output when I plug in 3, so I can turn on my y-axis, right? So you can see this is where all my outputs are. And if I look at where these things match up, right, kind of like crosshairs, right? I plug in 3, I will get out a value of 3, right? So that's how I look at inputs and outputs. So if I ask something different like, oh, when is my function going to have an output of, let's say, 0? I'm looking then at the output lines, right? When is my output going to be 0, right? So where do these things cross? They cross here at a value of 12, right? So the only time I have an output of 0 is when I plug in 12. Okay, so that's how we look at inputs and outputs in our functions using a graph. And we can, of course, calculate these things by plugging in values or setting values equal to the outside. Hope this helps.